Okay, so in this video, I was probably going to have to break it up into 2 or 3 videos. I want to talk about the remaining slides I didn't get a chance to talk about, so that would be about 45 some slides. And I'll post these on YouTube, and then next week, or the week after, the week that I get back, we'll focus on solving problems. So we had left off the discussion with a discussion of costs and how costs look in the short run. If you remember, to put this back into perspective, at this point we would have finished talking about production in the short run. And with that we had a production curve that was moving first where labor was becoming more productive and then less and less productive. Well, these are the costs that are associated then with that change in the productivity of labor. And so what we, when we look at these slides here, the difference between the short run and the long run, again, is that in the short run, some of the costs are fixed. In the long run, all of the costs are variable. And I said that for right now, we can kind of skip this discussion of sunk costs, that the greater focus is on the fixed costs. So these are costs in the short run, and when we look at that, one of the first costs that we have is the total cost, where the total cost is simply equal to the fixed costs, which do not change with quantity, plus the variable costs, which do change in quantity. And I said for right now, we do not need to worry about this. This is slide 70. Sorry, I'm moving in the wrong direction for some reason. Marginal cost, as our second kind of cost here, is actually talking about the slope of the total cost curve, as well as the slope of the variable cost curve. And you can see that in these kinds of equations here, right? To use the calculus term, this would be the first derivative of the total cost function. But we could also just see it as the change in variable cost over the change in quantity, or the change in total cost over the change in quantity. Then we have the averages. That's simply your, in this case for average total cost, here would be your total cost divided by the quantity. And when we put all of these costs together, the variable cost, the marginal cost, the total cost, the fixed cost, and the averages, we could create a chart like this. And this is basically where I'd left things off on Wednesday's lecture. You'll notice that at quantity 0, that the variable cost is 0. That should make sense, right? You should have no variable cost when you're not producing anything. The fixed cost is always the same. And then what you can do here is you can see that there's a way in which you can track how fixed costs, here, column 1, plus column 2 equals column 3. How the change in column 3 for each quantity, or the change in column 2 for each quantity, gives us column 4. How column 5 is simply column 1 divided by the quantity. How column 6 is simply column 2 divided by the quantity. And how column 7 is simply column 3 divided by the quantity. Now, again, this short-run cost curve, its shape, its entire shape, and this is important, its entire shape is given to us by the production curve. The production curve is what motivates it. It's a mirror image of that production curve. So why would that be, right? In the beginning, and this would have been the last things that should be in your notes from Wednesday. In the beginning, when the workers are becoming more and more productive, that means that your costs are not changing as much or as quickly, right? Then, when the marginal product of labor starts to fall, as we get in the top bullet point here, then your cost of production start to increase in a greater fashion. That would mean that your marginal costs are rising. And you see this here, right, that the marginal cost is initially falling and then rising. And you can see that in the table if you go back on your own. that the variable cost curve starts at 0, first increases at a decreasing rate, and then increases at an increasing rate. Total cost curve is the exact same shape, except it starts at the fixed cost. The fixed cost does not change with quantity. And you can see as well that the marginal cost curve intersects the minimum of the average cost curves. That by mathematical definition, that the average cost curve, whether it be variable or total, that the average cost curve has to be falling when marginal cost is below it, and that the marginal cost curve, right when it's above it, it would have to be rising. And so then, therefore, the marginal cost intersects the average curves at the minimum. Okay. The marginal cost curve obviously would be the slope of these curves as well, of the total cost and the variable cost. Now, slide 85 is important. And slide 85 is important if not only because what it does is it tells us how things change in the long run. And costs in the long run, now the firm can change how much labor and capital it's using. Labor, the price of labor being the wage rate, the price of capital being the rental rate, or R. Even if it's not renting, we still consider it that. This gives us an ISO cost line. This ISO cost line looks exactly like the consumer's budget constraint. That ISO cost line would say for a set cost, or a set firm's budget, that would be equal to the wage rate times the quantity of labor, plus the price of capital, which is the rental rate, times the amount of capital. That slope would then be the negative of the price of the input on the x-axis, typically that would be labor, divided by the price of the input that's on the y-axis, typically that is capital. It doesn't have to be, but typically it is that way. And you see some ISO cost lines here. The intercepts are important. Obviously that would be your total budget, 150 for instance, divided by the price of capital. And then the slope again here would be the negative 1/2, right? Because that would be negative price of labor, which is $5, over $10, which is the price of capital. And so here's the decision then. If the firm is trying to minimize its costs in the long run, and it can change the amount of labor and capital it uses, then the issue is what is the cost minimizing combination? How can they produce the stuff they want at the cheapest price? What they need to look at is the ISO quant. So they need to know how much it is that they're going to produce. So when we put it all together, this slide becomes important as well, because what it essentially does is it becomes becomes very similar to the consumer's optimal choice, where again, we're looking for the point of tangency between the ISO quant, Q1, and the ISO cost, C1. That cost minimizing combination would then be L1, K1. And as you think about how you solve these problems, you solve them exactly the same way that you would solve the problem if you had been faced with a consumer's optimal choice. Set the two slopes equal to each other, cross multiply, and then substitute. Now, we can also change the price of various inputs. That's obviously going to make the curve flatter or steeper, and that's going to change the optimal combination. This slide then obviously becomes important. Hopefully it's actually rather simple as well. Take note that the second equation is basically highlighting how it's rise over run, delta K over delta L, and why it actually equals W over R. This line right here indicates that basically firms then are minimizing their costs given the prices of the inputs. When we take the slide further here, the last bullet point is incredibly important for this section. it essentially says that firms, we know that they're operating in an optimal fashion when the last dollar spent produces the same amount of productivity per input. If an input costs 10 times as much, it better be 10 times as productive. And when we take that and see just a kind of a a sample problem here, where MPL and MPK are both equal to one another, right? If the workers are 5 times more expensive than the capital, but they're equally productive, what would they want to use? Well, they'd want to use a lot more labor, right? Because the labor is delivering productivity at a cheaper cost. Okay, I'm running up to the time limits that YouTube lets me post videos, so I'm going to stop the video here and then pick it up with slide 96.